Whenever you see an exponent in the rule, that means it's a geometric sequence. Because it doesn't say that specifically, just know exponent is geometric. And if you think about the general rule, the base of the exponent is always your common ratio. So the base of our exponent is 5/4. So that means that our common ratio is 5/4. So we're going to use this rule here. We already know our first term. And our first term would be -2. So that's our first term. So T1 is -2. But now to find T2, whenever the exponent only has an n, you would have to go down 1. I think that's a little bit confusing. So I think in order to make sure you don't miss this on the test next week, anytime you see an exponent, just make it n-1. So to find T2, you're going to take -2 and then 5/4 to the power of 2 minus 1. T3 is -2, 5/4 to the power of 3 minus 1. T4 is -2, 5/4 to the power of 4 minus 1. All right, go ahead, type those in and get your second, third, and fourth terms. A sub n is the general rule. And you can use an A, you can use a T. I don't think I wrote this during 5th period, but I wrote these during 6th period. Those are your two arithmetic.
Yeah.
And then geometric would be T sub n. Yeah, you could just use any variable. You could use JN for Jasmine. It doesn't matter. Whatever letter you want to, it's just a variable. Okay, what did you get for the second term? -2 point who? Oh, yeah. I wrote it wrong. Yeah, so -5/2 or -2.5. You could write it as a decimal. And then for the next one, what did you get? Everybody change it to a decimal? Okay. Or it would be what? Negative. Is that right? 8. There we go. Or, and then the last one would be okay. And again, you could change all of those to decimals. So Jasmine asked a good question. A lot of these variables are interchangeable. It could be an A, A lot of books always use A. I think the most common is T for term, but it can be any variable. But the main thing is this does not tell you that it's geometric. You have to know that it's geometric because there's an exponent. And when you write a geometric rule, the first number is the first term. And the base of your exponent is the common ratio. That is your common ratio. All right, any questions about number 3? Let's go to number 4. What kind of sequence is this? We go from 160 to negative 40 to positive 10. Geometric. And again, if you don't remember, if it's difficult for you to see, to find your ratio, you take the second term and divide it by the first. Yep. So you could write this as negative 1/4 or negative 0.25. So go ahead and write your rule. And when you write your rule, again, it doesn't matter what variable you start with, but I'm going to start with T sub n. And then you start off with the first term, which is 160. And then your common ratio is the base of your exponent. I'm going to put mine in parentheses. And I'm going to use the fraction. And then to the power of n minus 1. So now use this rule that we just wrote to find T6. All right, who agrees with my answer for number 4? All right, a couple more for the day. Number 5, go ahead, write your rule. So I'll give you a couple minutes to write your rule. We have our first term. It told you that it's geometric, so find your common ratio and write your general rule. So remember to find the common ratio. If you're not sure, take the second number and divide it by the first number. And you can write that as a fraction or a decimal. All right, go ahead and check so far. So T1 was negative 8 and a common ratio. Who had that, 1.5 or 3/2 for your common ratio? If you take negative 12 divided by negative 8, you get 1.5. And then I wrote my rule. And the last step is use that rule to find the 8th term. And I got negative 136.6875, which is probably, did anybody write it as a fraction?
Negative 2187.
Yep, or negative. Yep, either one would be perfect. Keep on going. A lot of this is repetitive, so I feel like, you know. But now we have our word problem, and this word problem is on our test. Oh, sorry, I skipped the whole page. Let's go to number 6. So number 6, they told us the 6th term and the common ratio. And we have to figure out what do we have to know in order to write a rule. And I added this question. This is like number 20, well, it says homework 26, but it's actually for you all, homework 24. So this is a question that's like a question in homework 24. I just kind of added it so you can see it before you do your homework. Okay. So we need to know the first term and the ratio. They gave us the ratio. And we need to use that ratio to find, we need to use the information they gave us to find the first term. So T sub n is the number. That would be negative 243. That's going to equal the first term times the common ratio, which is negative 3. And what's going to be my exponent? What term is this? Negative 243 is what term? 6, so it's to the power of 6 minus 1. So we got negative 243 equals T1 times negative 3 to the 5th. Let's figure out what negative 3 to the power of 5 is. Make sure you're using your parentheses when you type it into your calculator.
Would it be the number?
So if you type that in your calculator, you get negative 243. Divide both sides by negative 243 to find T1, and that means that T1 is 1. So the first number in our sequence is positive 1, and we're multiplying by negative 3. So now let's go ahead and write your rule. So to write our rule, that would be T sub n equals 1 times negative 3 to the power of n minus 1. Now use that rule to find T9. All right, what you all get for the 9th term? 65, 61. Anybody else get 6,561? All right, try to do the next one by yourself. See if you all got it. So this time we know T5 is negative 64 and R is positive 2. Find T1, write the rule, and then find T9. All right, I'll give you a minute to compare your answers to mine. Make sure I didn't mess it up. You know, this is my first pre-calc class of the day. So when I solved for T1, I got -4. Raise your hand if you got -4. I'm just trying to see who with me. And then you had to write your rule, which would be -4 parentheses 2 to the power of n minus 1. And then we use that rule to find the ninth term. All right, skipping over number 7, let's go to number 8, which is a test question. It's the bouncing ball. The bouncing ball. So it says that Kimmy was playing tennis. After one hit, the tennis ball continued to bounce and eventually stopped. The highest point the ball reached was 6 feet. The highest point of the ball was 6 feet, I should say, not highest. So that's my T1. Each time the basketball bounced, it rebounded to 2/3 of its previous height. So this is my T1, and I'm multiplying it by 2/3 because it's rebounding 2/3 of its previous height. So why is this geometric? It's because we're multiplying the height by 2/3. So now let's write our rule. T sub n equals 6 times 2/3 to the power of n minus 1. So this, I like to kind of draw this diagram. I'm not the best artist, so sorry. So every time, so the ball started off at 6 feet. So this is my first height. And then after it hits the ball, the second time, this would be my second height, the third height, the fourth height, the fifth height, and the sixth height. So because it says what is the height after it hits the fifth time, what do you think I'm substituting in? 6. You're going to plug in a 6. So use your general rule and substitute in a 6. So this would be the first height. That's the initial height. And then after it bounces, the next time is the second height. And then that's how that goes. So go ahead, plug in a 6. And as a fraction, you get 64 over 81 feet. And as a decimal, 0.79. It didn't tell us for the round, so I'm just rounding to the hundredths place feet. No. So, so yeah,
After the first hit, so it's technically the 6 bounce.
right. That's why I drew this diagram.
That's why it says after.
Yes, yep. I knew I didn't have everybody's full attention, so let me go back and explain the diagram again. So this is the initial drop right here. This is my initial height. After it hits the ground, when it rebounds, this is my second height. And then it hits the ground the second time, and this will be my third height. That's why we need to pay attention. That's why I was trying to pull everybody together, because this is on the quiz next week. So, and I think that keyword after, you have to remember that if you plug in 5, you would not be getting the right height. Okay, so that's why I was trying to do this little diagram, and you know, you're going to plug in 6. Now use that information and try to do number 9. And it's the same answer as 8A is 9A is geometric, because you're multiplying the height of the ball. So yeah, when it says rebounds 2/3 of the previous height, if it's rebounding 3/4 of the previous height, if it's rebounding, that means you're multiplying it by 3/4. A lot of time the word of is an indication that you're going to multiply. And it didn't tell us where to round, so I'm going to round to the hundredths place, or the hundredths place for this example. But I will make sure that on the quiz it is clear where to round. So who got 9.49 feet? And usually when I grade it, I know that if you got part C right, you probably got part B right. And I don't even look at A and B. So in order for you to get part C right, you would have had to get the other 2 right. Yes. Yeah, I didn't. Well, let me see. Did it tell me the fraction? 12/15 over 128? Yeah. Okay, last question. I'm going to give you a minute to try to do number 11. We're skipping 10. Try to do 11 by yourself. So remember, it says, when it says find the nth term, that means write the rule. Now for this one, because your T1 is a repeating decimal, it's probably, well, it is best that you write it as a fraction. So who got 1.3 repeating? Does anyone know what that would be as a fraction? 4/3, yeah. Now, the only reason why is because it's going to change. If you use 1.3, it's going to change the 15th term slightly. Actually, I don't know. I haven't tried it. I would guess that it would change it slightly. So it would be 4/3 times 3 to the power of n minus 1. That's your rule. Now use that rule to find the 15th term. It does change it, yeah. Some fractions it doesn't matter, but if you have to round it, then it's going to change the accuracy. So I would recommend you use 4/3. Now, if I were to take off something, it would just be like a half a point. That's even if it's relevant on the test. I don't even know. I haven't looked at it to see if you're going to have a fraction for T1. Like, I don't know. I doubt it, but we pretty much made it very straightforward so that, you know, since there aren't any retakes on this last one, I don't think we gave you anything that would be like a trick question. So we got a lot of money again. So we got 6,377,292. 6,377,292. Who had that answer? If anyone needs help typing these in your calculator. Now we are finished, but I do want you all to write down the rules. Can we go to page 11 and fill in that box so that we're ready for tomorrow? It's our last formula. So take a moment and fill in. This formula is a little complicated for a geometric sum. And I'm going to write that over here too. So geometric sum formula is kind of ugly. And then I have some flashcards if anybody would like some, so you can start memorizing these formulas, since they won't be given to you. So, yep, go ahead and fill this in. So you have your common ratio, which is numerator and denominator of your fraction. And then you have T1, which is in the front of the parentheses. And we'll practice working with this formula tomorrow.